Hello class. The last topic in Module 1 is formula manipulation. So what I've made for this course is a handout containing 40 formulas. And what we're going to do is solve the formulas for the indicated variable. So I'm going to work through the even numbered problems with you, and I'm going to leave the odd numbered problems for your practice. So we're going to begin with problem 2. We're going to solve it for capital L, which represents the inductance in the circuit. Okay, I've got them set up already. So here's problem 2. I've highlighted the variable we're going to solve for. Okay, in isolating capital L, all we need to do is divide both sides of the equation by 2 pi f. The implied operation was multiplication, so we simply do the opposite, which is division. Here's problem 4. We're trying to solve for the variable little t. It happens to be in the denominator here. So the first thing we'll do is use multiplication instead of division to get that variable out of the denominator. So we end up with p times t is equal to w. Now in isolating t, we have to move p. Here we use division. Instead of the implied operation of multiplication, we do its opposite. And there's our formula for t. Okay, let's look at the next one. P is I squared R. We would like a formula for I. So first we get a formula for I squared. This is done simply by dividing P by R. Now that we have I squared, in moving to a formula for I, we do the opposite of squaring, which is square rooting. So we take the square root of both sides of the equation. And that gives us the formula for current. It's equal to the square root of P over R. Here's question 8. We're going to solve for P. It happens to be under the square root sign. So first we have to eliminate that square root sign. That's done by squaring. So both sides are squared. Now to get P by itself, we do the opposite operation. So instead of the multiplication on the other side, we will use division. And we get this formula for power. Power is V squared over R. Take a look at question 10. We're solving for this quantity, NS. It is squared and it's in the denominator. But what we have here is called a proportion. It's two ratios set equal to each other. Cross multiplication is nice in this case. So let's multiply this way first. NS squared times ZP is now this way. NP squared times ZS. If we want to isolate NS, first we isolate NS squared. We change multiplication by ZP into division by ZP. So the right side has ZP in the denominator now. This is an S, sorry. And now we can move from NS squared to NS simply by taking the square root of the right side. So we'll have a large square root sign here like this. And that's pretty great. The only thing we could do to further simplify that is to recognize that the square root of NP squared is NP. So that can come out, leaving the square root sign over this part, ZS over ZP. Okay, here's number 12. Kinetic energy is 1/2 mv squared. To get the m by itself, we have two things to eliminate. The fraction 1/2 and the multiplication by v squared. How can we eliminate the fraction of 1/2? Well, we can divide the other side by 1/2. But dividing by a half is the same as doubling or multiplying by 2. So we end up with 2 times the kinetic energy is mv squared, like this. So both sides are doubled. Getting the m by itself, simply divide by v squared. And that will leave m here. So there's our formula for mass in number 12. Okay, problem 14. Whenever I'm solving for the quantity in the bracket, I'm going to actually open the bracket up using the distributive property. So we end up with I times R1 plus I times R2. We want a formula for R1, which is in this term. So this term has to move to the other side. So we will be subtracting. So the term is subtracted like this. From addition to subtraction. We want R1 by itself. We simply have to divide both sides now by I. So I will be the denominator here like this, and we'll be left with a formula for R1. Okay, remember question 4, when the variable was in the denominator, the first thing we did was multiply like this. We're going to do the same thing here. When we multiply e by this denominator, though, we have to recognize that it's a binomial. It's two terms, so that means we actually need a bracket there. So the multiplication requires a bracket since this is a binomial. Now we're solving for the quantity in the bracket, so just as we did in 14, we open this up now. Like that. We're trying to solve for R, capital R. It's in this term, so this term must be moved. Isolate the term containing capital R. We use subtraction to move this term. And finally, to get capital R by itself, divide by little e. So it will be underneath the two terms like this. Okay, here's 18. We're going to solve for capital X, the reactance in the circuit. Now, it is under this large square root sign, and the square root sign is isolated. So we begin by squaring both sides. On the right side, the square root sign is eliminated. On the left side, we have z squared. We want a formula for x. So first, isolate x squared. Change to subtraction of r squared on the left side. And now, in moving from x squared to x, we have to square root. So we must show a square root sign like this over the difference here. Notice this is not the same as z minus r. You cannot split the radical if it's a sum or a difference. Okay, we're going to do 4 more together before having a break. Number 20, we want a formula for V0 or V0. First, isolate V0 squared. That means this term moves to the other side where it will be subtracted. Like this. And lastly, similar to the problem we just completed, we now take the square root, and the square root will remain over the 2 terms here, like this. Here's 22. We want a formula for capital R. It is under this large square root sign. It's also in the denominator and part of a binomial. What should we do first? Eliminate the square root sign. Since the square root sign is isolated, we simply square both sides and we get this. The variable's in the denominator. We do this multiplication now. It's a binomial, so make sure you introduce a bracket here. Open up your bracket. Like this. Now we're solving for the capital R here, so we isolate its term first. This term, therefore, moves to the other side using subtraction. The opposite of the addition here is subtraction. The formula should be for capital R, so all we have to do now is divide by I squared. Like that. And there is our formula for capital R. Okay, 2 more problems. Number 24. We want a formula for VL. It's trapped in the numerator here because of the denominator. So it would be helpful to start like this. Use multiplication first to get this. Now remember, on that right side, this means the same as a negative VL plus a VOC, like that. So if we want a formula for VL, we're going to have to first get one for the negative of VL. So that means we subtract VOC like this on the left side. Now, how do we move from negative VL to VL? We simply have to multiply both sides of the equation by -1. So we multiply the right side by -1. Now we have to also multiply the left side by -1. Now, a reminder, again, it is 2 terms and both must be multiplied by -1. So we will end up with first term negative and the second term positive. Which is great, just like this. If you want, you can write the left side in this way instead, which is a little more conventional to show the positive term first minus that second term. Okay, one more. We're solving for average acceleration, which is part of this term. So that means move the other term first. It will be subtracted. Okay, not bad. Now, to get it by itself, we have two things to eliminate. A factor of a half and the multiplication by t squared. Let's eliminate the factor of 1/2 first. This is done by doubling both sides. So that will leave us with a average times t squared on the right. We have to double the left side and it's a binomial. This requires a bracket like this, 2 times the left side. Lastly, to get the acceleration by itself, we simply have to divide both sides by t squared. Just like that. Okay, so I'm going to pause there. I would like to suggest that you begin working on the odds numbered problems. You can begin at 1 and you can stop at 27 for now. So 1 through 27 odd, give those a try. The answers will be posted in Blackboard. I will be posting a second video where I begin here at 28 and continue on until 40 with the even numbered problems. These ones are multi-step and more difficult, and so I think that a break here before those problems is warranted. Okay, thanks a lot. Have a great day.